Hello everyone, welcome to fourth lecture of Introduction to Java Programming. I am Jamal Nasir. Previous lectures to watch, so playlist name is Introduction to Java Programming. So do watch lecture 1, lecture 2 and lecture 3 before starting this lecture 4. So in the previous lecture we saw how to use system.out.println command, right? So it is a statement that prints a line of output on the console. We can pronounce it as println or println. So three ways to use system.out.println, like we can give string, right? Or we can give it a variable text, value would be printed, or it could be empty. Then we discuss about strings, that a string is a sequence of text characters. It starts and ends with a quotation mark character, right? And obviously the code do not appear in the output. And examples are hello, this is a string, it's very long. And we also discussed escape sequences, \t, \n for new line character, and we can add escape characters for adding quotation mark in our string, or even we can add an extra backslash to print one backslash. So this is the example, like if we want to print, then we can simply provide escape sequences. So today we will see expressions and variables. Both are very important. Like for any programming language, these are basic tools. Expressions, with the help of expressions, we can make statements, right? And what is a statement? It's a one instruction. So in programming language, in any programming language, we give instructions to do specific task. As we know that the computer's view is 0101 thing, that binary representation, right? So internally computer stores everything as ones or zeros only. Like we can represent small h as this one, it's ASCII code, right, converted into 01 format, or it could be a string high, like for each character we would have some code and then we can convert it into 01 representation. And 104, obviously if it's a number, then we can also convert it into binary. But how we can differentiate between this h and 104, right? Because both of them have same representation. So to tell this difference to computers that this is not h or this is not 104, we have to use types of that data. Okay, data types. So constraints the operations that can be performed on data. Many languages ask the programmer to specify types. So there are so many languages like Java, C++, right? They do ask data types of variables. But there are some languages, for example, JavaScript or Python, right? So, but in most of the languages, user has to provide, or coder has to provide, data type of the variable. And this type example could be integer, real number, or string. So Java has some primitive types, right? They have 8 simple types for numbers and text. Okay, so we can use these primitive types of Java. Java also have some object types, but obviously we will talk about this thing later on. So for example, int is one primitive type of Java, widely used, commonly used to store integer values. Okay, discrete values, not continuous values, and it has some range to store values. Then we have double, real numbers, used for real numbers. Character, to store a single text character, A, B, C, right, or any exclamation mark. Then we have Boolean, which is a logical value true false. So these are Java's primitive types, right? Byte, short, int, long, float, double, character, and boolean. And you can see its size, like how much we can store like values, right? This is the range of minimum and maximum value that we can store in a particular variable having this specific type. So integer or real number, obviously we can decide on the basis of our need. Like for example, if we have to store temperature in degree Celsius, then what do you think? What is the best thing to use this thing, right? What it could be? So temperature, if let's suppose, obviously temperature could be 9.5, right? So obviously it would be real numbers, in real numbers. Similarly, the population of lemmings, yes, population is discrete. So it could be 2 million, it could be 1 million, right? So we can store in integer. Your grade point average, GPA, CGPA, it would be real number, right? A person's age in years. So yeah, someone could be 23 years or 25-year old. Then this could be stored in an integer. A person weight in pounds. So yeah, it would be here. So any floating value, if we have to store any floating value, decimal values, then we would be using double. Okay. Otherwise, that integer would be fine. So expression, a value or operation that computes a value. Okay. Like 1 plus 4 multiplied by 5. This is one expression. This is another expression. And then this is another expression, right? Hello world. So the simplest expression is literal value, that 42. Yeah. So this is the simplest one, but this contains different digits and different operators. We will see these operators, right? So a complex expression can use operators and parentheses. So in Java, we have arithmetic operators. Like, what is the functionality of an operator? It combines multiple values or expressions. Addition, we can do addition. Subtraction, multiplication, division, and modulus, which is a remainder. Okay. As a program runs, expressions are evaluated. So 1 plus 1 evaluates to 2, and then system.out.println 3 into 4 prints 12, right? How would you print the text 3 into 4? Because if we print like this, then this expression would be evaluated to 12. But if we want only 3 into 4, then we will put simply double quotes before 3 and double quotation after 4, right? Integer division. So obviously if we divide 14 divided by 4, the answer would be 3, not 3.5. Okay. So if we are dividing integers, it will discard the remainder thing. It will only give the quotient value. So yeah. So 14 divided by 4, answer would be 3. For 45 by 10 is 4. So what would be the value of 32 divided by 5? 6. Yeah. And Yeah, for 84 divided by 10 is 8, right? And 156 divided by 1 would be 1. Obviously, dividing by 0 causes an error when your program runs. We have another important operator, modulus operator, or we can say that it will give us remainder. And in many tasks, we do require remainders. So this modulus operator would work as this, like if we have 14 divided by 4. So this would be the modulus answer, mod answer, right? So like if I divide 45 by 6, then obviously I will get 3 as a remainder. So this would be the answer of this one. Here I will get 0 remainder, right? As 8 is lesser than 20, so 8 would be the answer, right? So applications of modulus operator, we can obtain last digit of a number by dividing it with 10, we will get 7, right? Similarly, if we want last 4 digits, then we can simply multiply, use 10,000 with the mod operator. So if we want to check that particular number is even or odd, then the logic is simple, that if we are getting like this thing, obviously we will get 1. So it is an odd number. 7 is an odd number. But if we do this thing, we will get 0, and 0 will show that this is an even number. Okay. So we have precedence, PEMDAS, remember, like in early maths classes, that we have parentheses if we are going from left to right, right? And we have parentheses, exponential, multiplication, division, addition, and subtraction. So in terms of Java, we can say that instead of exponential, we can say that modulus operator. So obviously this parenthesis has the greater or greatest precedence. Then we have mod and multiplication, right? And division. This is addition and this is subtraction. So this group has the lowest precedence, and this one is the middle one, right? So whenever we have some expression, we will use this PEMDAS thing, right? In our case, in Java, we, instead of exponential, we can say that M for modulus, right? So it would have greater precedence over plus and minus thing. But if we have some parenthesis, then obviously that parenthesis would be greater precedence. So parenthesis can force a certain order of evaluation. We can see like if we have 1 plus 3 into 4, simple, right? In terms of PEMDAS, this would be 12. 1 plus 12 is 13, right? But now we have parentheses. So obviously this will be evaluated first, and the answer would be 16, right? So here we can see one precedence example, or in fact 2 examples. So here you can see, because this operator, multiply operator, has greater precedence, then so we will evaluate this, right? And then this one, because from left to right this operator has greater precedence, and then mod operator. Okay, so if we if we have some tie between this group, then obviously from left to right we will see. Okay, from left to right. Okay, from left to right. So yeah, so then finally this would be evaluated. Similarly for this example, um, from left to right, both belongs to same group, but from left to right thing, this division has greater precedence over this one. So this one would be evaluated first, 8 divided by 3, and because of integer thing, we will only get the quotient or only integer value, which is 2. So then now we have plus operator, multiplication operator, and minus operator, and this operator has greater precedence. So we will multiply these two numbers. 2 into 2 is 4. Now plus and minus both belong to the same category, right? But because of this left to right precedence thing, we will evaluate this thing first. So 1 plus 4 would be 5, then 5 minus 9 would be minus 4 would be the answer of this expression. So you can pause this video and try yourself that what would be the result of the following expressions. So yeah, you can pause this video. So real numbers, double example is 6.02 or minus 42.0, right? Or it could be any exponential number. So placing 0.0 or point after an integer makes it a double. The operators all still work with double, right? Obviously, maths operator, so it will work on double as well. So, but obviously, if we are using some divide, so if we are using divide operator, then it will give you an exact answer. Okay. So 15 divided by 2 is 7.5 now. So precedence is same. So these are the real number example. So in terms of precedence, multiplication left to right, then second multiplication, and then we would go for divide, and finally we will add these two numbers. Precision in real numbers, the computer internally represent real numbers in an imprecise way. Yeah, so if you can print system.out.println 0.1 plus 0.2, you will get some sort of this answer. Okay, so yeah, mixing types, yes, we can mix int and double, and obviously when we would be mixing int and double, we will get double. Okay, so this is another example. For strings, we can concatenate. We can concatenate different strings. Okay, so if we add some integer to string, it will add as a string. Okay, so this is another example. Here we are concatenating grade with this thing, and but because of this parenthesis, this expression would be evaluated first, then divided by 2, and then this plus has precedence. So then the final answer would be concatenated with the grade, which is 83.5. Variables. So let's assume we have one receipt example. So like if we have some bill from any restaurant, so obviously it will contain different items, right? Price of an item, let's suppose we took these three items of cost, this one. Then obviously for this total we have to pay tax, right? And if we want to add some tip, then tip would be added here. Okay, so we can make simple Java program which can compute your total bill. So you can simply put all the values directly into println. Then for this total amount you can compute 8% tax, or even it's 23% tax, right? Then if you want to give 15% tip, right, then you have to compute again, and then the total amount would be this one. Obviously this is very cumbersome and difficult to write, and obviously we have more chances of mistakes. So and a lot of system.out.println statements we are using, and obviously we are repeating this statement again and again. So what is the solution? Okay, so solution is variables, using variables, right? So variable is a piece of computer's memory that is given a name and type and can store a value. So basically in our RAM, we just say, okay, we have one variable age, so we can store some value during this program execution. Okay, and obviously we would be storing what is the data type of an age. Okay, so similarly, just like cell phone keypad or anything 1 2 3, right, these are the variables which are storing some information. Like on some radio we can say one number is representing channel FM channel 100 or something, right? So this is a variable. So there are three steps for using a variable. We have to declare it, in which we have to write its name and type. Then we can initialize it, right? Store some default value in it. Then we can obviously use it. We can print it. We can use this variable to assign value of this variable to some other variable, right, as a part of an expression. So variable declaration sets aside memory for storing a value. Basically we set to memory that, okay, we need this variable, and we know that every data type has some size, right? 4 bytes, 8 bytes. So by this way we are saying that simply to RAM that, okay, I need 4 bytes to store one int. Okay, so yeah, because our memory is not infinite, it has capacity, so we have to tell, and then we can name this memory instead of like memory address CC1921. Obviously this would be very difficult to work on. Instead of this, we just calling it as a variable, okay, in our program, but at the back end this thing is happening. So syntax is type, name, right, int, zip code. So we are declaring one integer variable named as zip code. So in the RAM it would be represented as this one, and then we can store my GPA as double variable. So this is variable declaration. We can assign some value to the variable. So this is assignment. So simply we can assign, like here we are, let's say I'm saying age, and then later on I am assigning age is equals to 21, let's say. Okay, so what does it mean? That if I have one variable, then in the memory I am just updating its value to 21 here. In the next code, if I change its value to 29, then this value would become 29. It would be overwritten. Okay, we cannot restore the previous value until and unless we are storing this previous value in some other variables. But from RAM, if it's overwritten, then we cannot uh, undo our action, or we cannot get the previous value of this age. Okay, so using variables is simple. We can simply here we are declaring variable, assigning some value, and now we are using it. We can use it in system.out.println, right? Or we can use in some expression, or even we can use in some other variable, let's say. Okay, so in X, basically I am multiplying this with 20 and then storing its result with in B variable. And obviously before that I have declared what is B. So this is done. Declaration, assignment versus algebra. Yeah, obviously we cannot do this thing, right? This is assignment operator in Java, and it means that right side expression is going to be evaluated and its result would be stored in some variable. Here at the left side there must be some variable. So you can pause this video and see what is the output of this small Java code. Assignment and types. A variable can only store a value of its own type, right? So if you're trying to initialize one X variable, which is uh, integer with some real values, then obviously it is not allowed, and it is because it's incompatible types. Okay, so compile errors, a variable cannot be used until it is assigned a value int x, and then we can say uh, because the value is not initialized, so obviously it will give an error, right? And you cannot declare the same variable twice. Like in the one program, if you have initialize or declare x, then obviously you cannot declare x again. Same is the case here. Okay, so error would be there. How can this be fixed? Obviously you can just simply remove this int in this code, right? Then there is no problem. How to print a variable's value? uh, Very simple. We have to provide into system.out.println thing, and whenever we will saying like this, right, it will automatically get its value and it will be printed here. So with the help of variables, can you write this receipt old program in a much better way? So take your time, or you can pause this video and think how you can make this code more efficient in terms of using variables. So we can use variables like for bill, for items, we can use one variable as subtotal. Then we have to compute its tax. So subtotal into tax rate, right? Then tip would be subtotal into 0.15. Then we can simply add these three numbers and then we can simply print it. Okay, so you can see from here. So you can see from here we have so many like system.out.println statements, and we were repeating this thing so many times. Instead of this, with the help of variables, we can write our code more efficiently and there would be less chances of errors, and in terms of scalability or changing our code, it would be much easier than the previous code. Okay, people, this is about variables, so you must try and practice different primitive types of Java. Yeah, because practice makes a man perfect. If you have any question or comment, you can write on YouTube video section. Please like this video, share with your friends, and keep learning. Bye bye.